Okay, now we're gonna try making the neural network itself. Okay, first, neural array. The neural array is the base structure for creating a neural network. It just put all the neural network functions in here, and but we have to make some modifications here. Step one, shape. Okay, if we're gonna have convolutional neural networks, we need to be able to, where am I? Type shape. We need to be able to have a two-dimensional tensor. So we need a shape to move the neural data into. Okay, type shape.h. Okay. Okay, we have the shape, but now we need to create to something. Okay, we need width, height, and depth. Okay, where am I? Oh, there we are. Height and depth. Okay, so now we have to assign it. Type shape assign. Okay. Oh wait, type shape assign. Do you have it? CGN. Okay, I remember. Okay. Okay. Oh, we have to put it up here also. Type shape. No, type shape array shape. Okay, now we're getting this. Okay, parent dot array shape. Ah, width, height, and depth. Okay. Oh, what is it? I don't know. Why is it a different color? Oh, I'm missing something. I'm missing something. I'm missing something. Okay, I missed that. Width, height, and depth. Okay, now we have the shape. Data length equals type shape length. Type data length. Oh, we still need a length. We still need the length. Okay, we still need the length. Okay, length equals. What is type shape? Do I have it? Oh yeah, it's here. Type shape. Get length. Type shape get length. There it is. Okay. Get length. Parent.array shape. No. Oh, we need an end. So because it's a pointer. The pointer to a structure. Get length title array shape. Okay. Length, data length equals everything else is the same, I think. Alright, now we have to set the shape to 0 if it fails. Okay, where is it? Type shape 0. Okay, there we are. Type shape 0. Parent.array shape. Okay. Okay, length equals shape length. Everything else still stays the same. All the other functions don't use the shape. But when we do all the other stuff, scaling and convolution, we're going to need to use the shape. But for now, we don't need to change anything else except for this right here. Okay, right here. Okay, everything's right. Yeah. Okay, now we have type neural array. Now we need a neural layer. Okay, file new file, edit file. Okay, no, what am I doing? Okay, if and def type no neural layer. We're going to have a lot of layers, so we need to separate everything into its own structure. Otherwise, it's gonna get confusing. Define type neural layer. Okay, what am I? And if type neural layer. Okay, why do we need for a layer? Type def structure. Okay, type neural layer. Okay, what does a layer need? Okay, no, on signed long. We need layer type. Okay, no, layer type. What am I doing? We're gonna need a lot of details, but for now, let's just start with the basics. Type null array. Oh, wait, is it? Oh, include null array. Include type null array. No, null array. .h. Okay. Is it? Oh, wait. I'm in the wrong place. Wait a minute. Okay, I need to save the file. Oh, I completely forgot about that. Okay. Type null layer. Okay, .h. Okay, good. Type null array. Okay, layer outputs. Outputs. These are the 4 basic arrays. Wait a minute. Oh, shoot. Wrong. Wrong. No, layer outputs, not layer outputs. Okay, we need, in order to make a basic neural network, we need 4 basic arrays. The outputs, the weights, the vectors, and the deltas. Deltas. The output is the value as you feed forward. You copy one output to the next output and the next output in each from one layer to the next. Okay, the weights are the stuff you multiply by. The vectors are the derivative of each weight when you're updating, and the deltas are the derivative of the layers. You also need a bias, but for now I'm going to use a bias layer, which is the bias is just the weights of the layer. We're going to have to separate everything into each layer, just to be clear, but it's not actually necessary to do it. Like you can just have one type of layer and mostly. Okay, layer type. Okay. Type null layer create. Okay, type null layer create. Okay, long. Long is just a boolean. Okay, now I'm gonna decide how to do it. This may be a problem. Creating layers creates a slight problem because in order to calculate the size of the size of the weight, especially in the fully connected layer, you need to know the size of the next layer. So you can't just say height, width, and depth. You have to use a shape. You have to use the shape structure, and we don't like that. Okay, type shape. Type shape. No, type null layer. Layer. No, type null layer parent. Type shape. Layer shape. Type shape. Layer shape. Okay. In the basic layer, you don't need to know anything. You just assume that everything is the same. But in a fully connected layer, it's going to be important to know the size of the next layer. So this may be problematic here. I will figure something out. Okay. I'll just say width, height, and depth. For now, we're just going to keep it simple. If there's a problem, we'll figure it out. Okay, width, height, and depth, same as before. Okay. Okay, layer type. If parent equals 0, not equals 0, return 0. Okay. Now we need to create the layers. Okay, if type null array create. If type null array create parent dot layer outputs width, height, and depth. And there's gonna be problems later, but for now we don't care. And parents dot layer. No, wait a minute. Okay, even though we have the all four layers, for now we're only gonna create the first two, because this is what we call a null layer. Parent dot layer type equals. Oh, let me copy something here. Okay, I have to look up something. How to do enumerate. Sounds simple enough, but I actually never quite learned how to do that. Type, no, not type def, enum. Enum, as in enumerate. Type no layer, no type layer, no, no layer type, no layer type. Null type, no null type. No new, no new role type. That's just a generic name. It doesn't actually mean anything. Okay. No type layer null. Will that do? Yeah. We don't need anything. Type null. No, type null. We don't need to call it that, but I'm just trying to choose a name that fits. Not neural. Yeah, no. Okay, no. I can't type. Type null layer null. We just enumerate and null type, and that just gives us null type layer type. Oh wait, is that how you do it? Oh, turns out you don't actually need to call it anything. Just unsigned long will do. Oh, all this time I never actually learned how to do that. Anyway, type null layer null. It's a null layer. Later we're gonna have bias layers, and convolutional layers, and all sorts of other layers. But for now, just call it a null layer. Okay, if outputs and deltas. Outputs and deltas are always required. Other types are other arrays are optional, but outputs and deltas are required. Okay. Oh wait, we have to mem set. Okay, we have to set everything to 0. So that means we have to include the strings standard library. Include no, not that, strings .h. That's just for memory set. Okay, mem set. Okay, the parent 0 size of type neural layer. As we change the type, we have to set everything to 0. Otherwise, okay, mem set. Do I need that? Oh, it's not string, it's string. Oh, I mistype it. I got it wrong. That should fix it, I think. Okay, mem set. Alright, that's it. Okay, you said everything. Why didn't set it up here? Set it in here. If mem create parent layer null. Wait, am I getting it right? Yeah. I'm missing something, aren't I? Yeah. And parent layer outputs. Okay, I think. Okay, return 1. Return 1. If type layer create, okay, everything's set to 0, and we don't have to do anything else. Yeah, for some reason I don't want to do that anywhere else. Okay, type layer destroy. Destroy is slightly more complicated because we have to destroy everything. Oh, now I remember. I have to destroy this too. Type null array destroy. I keep forgetting I have to destroy everything because we don't know which one failed. Type null array destroy. Am I right? Yeah. Did I mistype something? This thing's giving me the impression I can mistype something. Yeah, I got something. Oh, I completely forgot that. And that's why I missed. Is it and? Okay, did I miss something still? Just give me the input. Oh, of course. Function, function. Yeah, now I got it. Oh, sometimes I just can't read. Deltas. Okay, we have to destroy both of them because we don't know which one failed. One of them failed, or both of them failed, but we don't know which one. So we have to set both to 0. Okay, when destroying it, if parent equals 0, we return 0 as always. Now we have to destroy everything. And then set everything to 0. Okay, return 0. Return 1. Okay, we have to set because we're using the same destroy function for everything, aren't we? Now I wonder if I should. No, I don't think I should. Because we don't know what was created. No, we don't know what was created. So neural layer destroy. That's the null layer. Neural layer create, neural layer destroy. Now for feed forward. Oh wait, get rid of that. Okay, for feed forward, neural layer feed forward. That's for the most basic. Okay, type neural layer parent, type neural layer next. Next. Because it's a null layer, we have to set a few basic rules. First of all, the parent shape and the next shape have to be the same size. Have to be the exactly same shape. Actually, not even the same size. What? Does it have to be the same? Oh no. Sometimes we have to do flatten, but instead of doing flatten, we just require it to be the same length. If parent dot layer outputs dot array length. No, what am I doing? Array length not equals next dot layer output dot array length return 0. Okay, it doesn't have to be the same shape, so we can do flatten. Wait a minute, you can do flatten without having to create a special flatten layer. It just has to be the same length. Return 1. Okay. Okay, how do we do flatten? We just use copy. This is a null layer, the most basic kind of layer there is. It doesn't actually do anything. No other copy, destination, parent.layer outputs, no, next.layer outputs. No. Next.layer outputs into parent.layer outputs. We'll just copy from one to the next, and we're done. No, just return that. Maybe it works, maybe it doesn't, we don't know. Just return that. Okay. Okay, so feed forward is just copy. Same for backpropagate. And neural layer backpropagate. Things are gonna get really complicated later, so I don't want to mess anything up. Okay, now we do the reverse. Next. Oh no, the destination is for. Oh wait. Oh, it's parent. Ah, in the wrong place. Okay, parent.layer output. The destination here is parent. Everything's the same here. Parent.layer deltas. Next.layer deltas. Next.layer outputs. Okay, there's backpropagate proper, but there's also another kind of backpropagate. Backpropagate outputs. For when you backpropagate the output layer, you have to subtract data from what am I doing? Data from an output, from an output array into the layer itself. But there are many different ways of doing that, so I don't think I should put it here. It's just put it inside the neural layer thing part itself, the neural network itself. Okay, we have feed forward and backpropagate. That's the most basic thing. And what am I doing? Okay, we'll clean that up later. Okay, now for the neural network itself. For that, we're gonna use image list. What am I doing? The same code that we use for image list. Okay, let's create a new file. Header file. No, if and def. Not if. Type neural network. Oh my god. OH. Fuck. Okay. Define. And if. Same thing as always. Okay. Type def structure. Oh, we should just copy image list. Okay, unsigned long, network linked. Okay, network linked. That dynamic way, network linked. Network linked. Network data. There's also the learning rate, but let's not deal with that for now. Okay, type neural network. Okay, neural network create. Okay, let's just copy this one also. Neural network page. Okay, neural network page. The size of type neural layer times, I think 10 is enough, right? Times 10. 10 layers should be enough. Okay, we have to include a few things also. Okay, type image. Why am I copying this? Type neural layer, and what else? Type dynamic array. Put them in order. Type neural layer, type dynamic array, save. Neural network .h. Okay, neural network page. So we just define it the way we want. Okay, type neural network, copy. Type neural network, copy. Type dynamic create a parent.network data. Network data, network page. Okay, neural network page. We have a page size. That's the page size, int. Okay, parent.network length equals 0. Parent.this.network length equals 0. Okay, what else are we doing? Okay, we need to destroy also. Where are we? Image list destroy. Just copy everything. Actually, that could prove problematic here. Okay, neural network destroy. Okay, type neural network destroy. Type neural layer. Layer pointer layers. and layers equals type neural layer parent dot network data dot array data. Okay, that's a problem here. Okay, that's something else I need to clean up. I think we should do that later, but this is a problem here because we need to know if layers, because this might the value might be 0. The value might be 0. This is something we need to clean up here. For I equal parent dot network length I plus plus type neural layer destroy. Where am I? Type neural layer destroy. Okay, type neural layer destroy, but so it's not that simple. Now we need a switch statement. Oh yeah. Okay, this is gonna take a long time. Switch layers dot I dot layer type. Okay, what am I doing? Switch layers dot I, not layers. Oh, if layers. Switch layers dot I. Okay, default. I don't need default. Case. Okay, this is just going to take forever. Type neural layer null. Type neural layer destroy layers dot I. Break. No, not break. Continue. Not just break. Break out of the switch statement. Not just break out of the switch statement. Okay, that should do it. I think it's getting late here. Okay, everything seems to be looking good. For different types, you just add it here, and that should do it. But let me correct this now. I must be tired. If images okay, edit, advance, format document. If images destroy. Okay, parent list then equals 0. Parent.neural network. Edit, advance, format document. Okay, we're getting there for now. The next thing we have to do is feed forward. Oh, I made a mistake somewhere. This goes up here. Oh, wait. I'm missing a few things. What am I missing? Yeah. Okay, that's it. So, did I miss it here? No. No, it's good. Here it's good. If layers, then for I equals each type of layer, and then for each type of layer we destroy. Okay, now we have to feed forward. Type neural layer feed forward, not neural network feed forward. Type neural network feed forward. No, type neural network. Parent. We'll do that. Finish that later. Right now it's getting late. But the basic idea is that for each type of layer, we just feed forward, same as here. We just feed forward from one layer to the next layer. We'll do that later. For now it's getting late.